Hi, welcome to the second demo video that's introducing you to the programming language R. In this video, we are going to see how you can use R's plotting abilities to be able to come up with some very simple basic plots. Typically, people that write code in R will use imported packages, which are it's code that's been written by the R community that people make available for anyone to use. And there's code that is able to produce really nice looking graphs and plots. But today we're just going to cover what R is able to do on its own without having to import some of that other code that people have written. So with that being said, let's go ahead and get started. You can see up here, first couple of lines, I just have that it's the second demo, our intro demo _2. On line 3, I introduce the data function. So the data function, there are data sets that are already built into R, so we can get a list of what those are by running the data function on line 4. So let's do that real quick. And we can run that, and a new page appears here in our view that has a list of a bunch of data sets. I've already picked some out, so I just wanted to show you this and how it works. So we're actually going to upload a data set by using this data function, and the data set is called chick weight. So let's upload that real quick. You can see that it's in my global environment on the right. So let's take a look at that, the structure of that. So chick weight, enter, and you can see it says classes, some information, group data, 578 obs. So 578 observations of 4 variables. We have weight, time, chick, and diet. So we don't have to worry about any of this other stuff here. Let's just focus on these 2 variables. We're going to be looking at weight and doing some plots with that. But as you can see, sometimes when you input a data frame inside of your environment, you kind of have to inspect it and see kind of what it looks like. So there is a number of functions that we could use. So you look at here on line 9, these are some useful functions that we could use to explore what our data frame looks like. So we have nRow gives us a number of rows, nCol gives us a number of columns, dim tells us how many rows and columns, structure is what we just saw. It kind of gives you a list of what the object is and what variables are in it. Summary will give us a summary of the things inside it. So let's take a look at these functions very quickly with the chick weight data. Okay, so let's run the head function. So we can see it returned the first 6 observations of those 4 variables. We have the weight, and that's in grams. This is another variable. These aren't necessarily that important. We're just going to use this data set to demonstrate a histogram later on. But if you just kind of wanted to see how these other functions work, the nRow is going to give us the number of rows that are in the frame altogether. There's 578, which means that they observed information of 578 chicks. So let's do the number of columns again to show you how it works. It tells you that there's 4 columns, and of course every column represents a variable. The dimension is going to give you the rows and the columns that are in this object. Let me clear this first, and let's run this line 14. So there's 578 rows and there's 4 columns. The structure, you've already seen that as well, kind of returns a the information here that we already saw. So summary does something similar. I'm going to clear my environment. So let's run summary. So summary takes all the variables, and when they're numerical variables, it gives you the minimum, the mean, the maximum, the median, the first and the third quartiles. So this is a pretty good function to use, the summary function um, that you can apply to an entire data set. All right, so now let's get to the graphing aspect of this. Okay, so we can do lots of different types of graphs. I'm going to show you histograms, scatterplots, and boxplots right now. So generally speaking, um, as I mentioned in the previous video, you can change settings within functions. If you know what the settings are, you can just put various settings within the function and change them and separate them with commas. So I'll show you that now. So if you look at line 22, I have histogram. So first we're going to use the function hist with the open and close parentheses. So that's how we're going to create a histogram. And my example here is, as you can see here on line 22, I put hist, open up that parenthesis. So that first space is, you're going to put your variable in there, as your vector variable in there. And of course it should be a continuous numerical variable because this is a histogram. It won't work if it isn't. The setting xlab stands for the label that's going to go on the x-axis. So you can see here that you put the setting xlab and then equal, and then in parentheses you're going to put whatever label you want to put in that x-axis. Similarly, for the y-axis, you use the ylab setting, and you set that equal to whatever you want to name that y-axis in between parentheses. So I put a comma here at the end, and I skipped down to line 23 to finish the settings inside of the hist function. So another setting is main, and you set that equal to whatever you want to call your title. Lastly, we have color, or col, which stands for color, and then you will put the color that you want your graph to be. So let's see an example of how this works. Chick weight is already in here, so we're going to use chick weight. So let's do chick weight, and we're going to do the variable weight. So if you look at here on line 26, I'm going to run this code. So I'm going to do a histogram of the numerical variable weight and see around how many chicks have any given particular weight. So I'm going to run that. So as you can see here on the right, the plot appeared on the bottom right corner. The x-axis just says chick and it has a variable, right? Because we were working with the weight variable, and that's in grams. So we can see the various separations here, and around how many chicks were between those weights. Remember, there were about 578 chicks. So we can see here that around 200 of them were between 100 and this is probably around 50, between 50 and 100 grams. Okay, so this looks sort of not that nice, so let's change these labels so that it can look a little bit nicer. So I'm going to go here to line 28 where I have another hist function open, but this one has settings in it that I'm going to set. So I'm going to do, once again, the chick weight, and then I'm going to call my x-axis chick weight in grams. I'm going to call my y label chick count. This is I'm going to just hit enter here and put this on the next line. And I'm going to call my main title frequency of chick weights, and in parentheses, that's in grams. In color, let's make this light blue. Oh, let's make this blue. Okay, so I'm going to run this code and hit run. So now we have our histogram with the labels that we want on there, how we want them. Okay, so let's make a scatter plot. For this scatter plot, scatter plots, as you know, they're going to take two numerical variables. So in order to do that, we're going to download another data set called the women data set. Okay, so just so you can see what it looks like, I'm going to pull up the first 6 rows here. So it's just a data set that includes 15 observations of heights and weights of women. So we're going to see if there is any kind of correlation between the heights and weights of women. So on line 37 here, back at my script, I'm going to use a plot function. And actually, and here on line 32, I've put the arguments as well of what we can do here. So let's leave it like this, simplify it a little bit. So this kind of plot, the settings are going to be the same. So the X label, Y label, main, color, they're all going to be the same. But here, the first argument is going to be what you want to be on the left axis, and then a tilde, and then what you want to be on the right axis, on the x-axis, I mean. So what you want on the y-axis on the left versus what you want on the x-axis. Okay, so let's show you how that works down here. So we can see that the two variables of the women data set are height and weight. So let's compare the women data set, the variable weight, and then we put that little tilde, and then do versus women height. Okay, so you know what, actually for right now, like I'm not even going to do the labels. Actually we could do the labels right now too. Let me simplify this a little bit. So let's do X label women's height, Y label women's weight. Let me move this code down here actually. So women's weight and main will be height versus weight of women. And let me put this over here. So the color will be red. So let's run this code. And you can see that we now have a scatter plot that shows women's height versus weight. And you can see that there does tend to be a positive correlation that's almost perfectly linear, at least with these the sample of women that we got. But we do know that there is a very high degree of correlation with height and weight. In general, the taller people are, the more they weigh. So this makes a lot of sense for the scatter plot. Okay, so lastly, let's take a look at how to do a box plot. So if you look at line 41 here, you can see that the function is boxplot, and I'm going to write that in here, boxplot in general, and pretty much you would set it up in the same way that we've set up these other ones. We got boxplot, and then we have the first argument is one variable versus another one. This horizontal equals false here just tells you whether you're gonna see your box plot in a vertical direction or in a horizontal direction, and I'll show you what that means here in a minute. The X label and everything else is exactly the same as you've already seen. So let's use this other data here called data sleep. So this data sleep, and I'll show you what it is. Data sleep, let's pull it up here. Let's do head sleep. So data sleep was a study where they collected the results of two different drugs being tested on people, and to see how that would affect their sleep. So they either got extra time of sleep, more hours of sleep, or less. Okay, so you can see here on the bottom, extra is a variable that captures whether they overslept or underslept. The group variable is if you can see down here, it's a factor with two levels, so there were two groups here. Okay, so we're going to make a box plot of this data set and compare the two groups versus the hours that they got to sleep. Okay, so we have sleep, and we want on the x-axis the group. So we want the group to be on the x-axis, and then we want extra, which is the hours of sleep that they got, to be on the y-axis. So let me just do this real quick, and then I'll show you what that horizontal thing means. Okay, so I'm just going to run what's on line 48. Okay, so you can see here this doesn't look quite right. Okay, so whoops. I'm sorry, I did it backwards. So let's do extra here, and let's do group here. Oops. Let's run that again. Okay, there we go. So the thing that's on the x-axis, on the y-axis, will be the thing on the left, right? And the thing to the right of the tilde is the x-axis. So I believe I said that backwards. So keep that in mind. Okay, so notice how the alignment isn't how we're typically used to seeing box plots, right? We're used to seeing them in the other way around, as vertical. So this is the default. So if we want to change the default, we're going to include that setting. Go back here on line 48, horizontal, and that equals, the default is false, so we're going to set that to true. And run that, and now they're on their side. Okay, so let me put that in here. So the default is false. So if you want the box plots to appear sideways like this, you got to change that to true. Okay, so let's let's add those labels. Okay, so let's do the x label equals, and that's oops, x label, and that is group, and then y label. Let's do that in the next line. Y label is hours over, under, slept. Okay, and then main equals group sleep hours. Okay, and then lastly, let's do a color. Color equals yellow. Right, so let's run this again. So now we have our box plot that has our desired X label, our desired Y labels, and the main title that we want. And you can see here that you can make this comparison between the two groups now. It's a lot easier to make. We know that the dark line in the middle is the median. We know that the maximum number is this line here, the minimum is here. The third quartile is the end of the edge of the box. The second quartile is the left edge of the box. And we can see that there does seem to be a difference between these two medians here. So that's how box plots work. And in general, this is how plotting works in the base R functionality.